Hey everybody, welcome once again to Welch's Math class. We are now again in Module 3 and working a little bit on something called the prime factorizations. Prime factorization, essentially when we prime factor a number or do a prime factorization, we're going to take the number that we're working with and break it down. We're going to break it down to its primes. And you say, well, what are primes? Well, the primes that we work with consist of 2, 3, 5, 7, 11, 13, 17, 19, 23. They go on and on from there. Essentially, a prime number is a number that its only factors, the only way you can break it down is with itself and 1. So for example, 7 is a prime number because the only way to break down 7 is 7 times 1. If you take, for example, a number like 10, 10 would not be a prime number, it would be a composite number. 10 will break down to 10 times 1, but it'll also break down to 2 times 5. Now all the numbers we have listed here can only be broken down to themselves times 1, so that makes them primes. Now we use a method of prime factorization when we use these numbers to break down another number to its primes, its prime factorization. I use a method I call upside down division. Let me give you an example of that. Suppose I want to do the prime factorization of the number 72. I want the prime factorization of 72. Well, I will do an upside down division house on the 72, and I'll start with my primes here, and I'll start with 2. I wonder if 2 goes into 72. Well, I know it does. You can check it with your calculator. I know it does, though, because 72 ends in 2, which is an even number. 2 divides into anything that is an even number. 2 into 72 actually goes 36. We can actually break down 36 now with the 2 also, and that'll get me an 18. And we can break down 18 with a 2, and that'll get me a 9. Now we can't break down 9 with a 2, but we can break down 9 with a 3. And so we break down 9 with a 3, and we get a 3. Now when we get to the bottom here, if our last number, or whenever we come up with a prime number on the bottom, we know that we're finished. So the prime factorization of 72 would be written in exponent form as 2 to the third power, that's 1, 2, 3, 2 times 2 times 2, times 3 to the second power, times 3 to the second power. So this is our prime factorization using the upside down division method for 72. Let's do one more. I want to do one that's a little harder. I want to take the number 351. Now, you may want to use your calculator on this, but I'm going to go with my primes and see what I can do with 351. I know 2 will not work on 351 because it ends in an odd number, not an even number. Remember, the evens are 2, 4, 6, 8, and 0. This ends in a 1. A 2 is not going to work. Now, 3, I believe, will go into 351. In fact, I know it will. There is a rule to figure out if 3 goes into a number, but you could just use your calculator, and you would see that 3 goes into this, I believe, 117 times. Okay? And then we'll use 3 again on 117. 3 into 117, I believe, will go 39 times. And then, gosh, we can use 3 into 39, and we'll get 13. Now, when we hit this 13 right here, we're going to realize 13 is one of our primes, and so we know we're finished. So the prime factorization of 351 is 3 to the 1, 2, 3 third power times 13. Okay, now I just want you to slide back into your practice. Go through your practice problem right here, do some similar exercises, go through and break down some numbers using the prime factorization method of upside down division and see how that works for you. And I will see you next time.